So we want to look at the application of exponential and logarithmic functions. Specifically, question 15 and 16 of this tutorial sheet. If you look at question 15, a population of bacteria initially has 90,000 present, and in 2 weeks, there will be 200,000 bacteria present. So this means that your initial is 90,000. Okay, and then you want to see how many bacteria are going to be there in 2 weeks' time, and you've been guided to say, oh, in 2 weeks' time, there will be 200 of them. So you understand that there is some function here that is moving this number from 90,000 to 200,000. And then look at A, determine the exponential growth equation for this population. So determine the exponential growth for this equation. So now we check. So how do we get the exponential growth of the equation? So exponential growth and exponential decay are both given by the same function. So we're looking at exponential and logarithmic functions. Match it into the applications. Okay, so specifically, we're into sheet 6. Question 15. Oh, this is 11:20. Okay, so the question says initially, so if I represent initial with a naught, initially we have 90,000. Okay, and then after 2 weeks, we have how many? 200,000. The question is, are you able to find the exponential growth equation given this information? So well, we know that the general equation is supposed to be pt is equal to n naught e to the power kt. So do you need to get worried about the sign of k? No. Okay, this information will drive the k. And whatever sign we get, that will be the sign for k. Okay? If the sign for k comes out to be positive, that means we have an exponential growth. If it comes out to be negative, that means we have an exponential decay equation. So now we're given that this is 200,000. So we are calling this to be pt is equal to n naught, that is 90,000. And then e to the power t, that is 2. Okay, so if we divide by 90,000, we divide by 90,000. Wow, it cancels here, and we remain with 20 over 9 is equal to e to the power 2k. But to reduce, to drop the power there, we apply the log function. So now we know we have that power coming down as 2k, and then we remain. Remember, ln is log of e. The base is e for ln. So this means that this side, we fix the ln. So we have this, that easy. And then what is log e? E, we know this is 1. So we get 2k is equal to ln 20 over 9. And then we divide by 2, and we divide by 2. So this gives us a value of k to be ln 20 over 9 divided by 2. So I can just say 1 over 2, like that. Well, so this, we can as well write it as ln. Remember, whenever ln has a coefficient, that coefficient can become the power. So we take it to be the power half, which is just a square root So that will give us the root of 20 over 3. Okay, so this is the value of k. And as you can see, the root of 20 is approximately, if I use a calculator, just to be sure, the root of 20 is 4 point something. So when you divide 4 point something by 3, you get 1 point something. So ln of 1 point something is positive. So why do I say so? Remember the ln function, the positive one, is drawn with this being the asymptote, and this is how it goes. So where this is 1 here, okay? So you see that for as long as the number inside ln, for as long as this x inside ln is greater than 1, then you're going to be getting the positive values, okay? But the number is bigger than 1 because you're now going this side, or these values are bigger than 0, like that. So they are not negatives. Okay, so it makes sense. This number is positive. The value of, so when the value of k is positive, then you are sure that what I'm getting here is an exponential growth equation. So you say, okay, the function p of t is equal to a naught, which we were given in the question, 90,000, and then e to the power t multiplied by k. So we'll start by writing t here, and then ln of root 20 over 3. Wow, so this is the solution when they ask you to find the exponential growth equation. So this is the equation. So what else? We are told to, how long will it take for the population to grow from its initial population to a population of 150,000? So it means that this time around, you are not given time. You are asked to find time because we have already found the value of k. Okay, we have already found the value of k. So the unknown thing that we have now is t. Now we are given that this population is going to be 150,000. Okay, when? We don't know. So we need to calculate. It's the only thing that is unknown because we know k now. Okay, so you divide again, divide by 90,000, divide by 90,000. So this cancels there. So we get 3 into 15, that's 5. 3 into 9, that's 3. So we have 5 over 3 is equal to e to the power t ln of root 20 over 3, like that. Okay, then you apply ln again. So apply ln this side, and apply ln this side. So that one drops. So we just have t multiplied by the ln of root 20 over 3 is equal to the ln of 5 over 3. Okay, then you're looking for t. So you say, okay, this implies that t is going to be the ln of 5 over 3, okay, divided by the ln of root 20 over 3, like that. So this is the time, because they're asking to find how long it would take for this to be. So this is our B, and this was our A for question 15. So when they ask you to find time, when they say how long, then you know it's time. Okay, how do you find it? You'll be given the value of PT. And then you have already found the constant and you have the initial. So the only thing that you don't know at that point is T. So you get it. So if you look at these two questions, they are different. The first question was saying, find the equation. And we are given the initial, we're also given the present value. And we are also told time when that present value will occur. So now we knew the only thing to find for us to have a complete equation is the value of k. Because we cannot fix time. Time keeps moving. You can't say just because after 2 weeks I had this, it will always be after 2 weeks. No. Before it became 2 weeks, there was some time there. Okay, so now I go to question 16. I think that's one that is more interesting. So let me take it to the question. Okay, question 16 says, we initially have 2 kgs of radioactive element, and in 7250 years, there will be 1.5 kg left. Initially, we have 2 kgs. After this time, there will be 1.5 kgs left. Determine the exponential decay equation for this element. So what do you do? Okay, so let's go there and see what we do. So we are told initially, there is 2 kgs. Okay. After 7,250 years, what a long time, there will be 1.5 kgs left. So this will be the present when you get to this time. What is the initial? 2 kgs. And they have asked us to find what? To find the exponential decay equation. Well, we know that the exponential is pt is equal to n naught e to the power kt. So you don't get bothered whether they say decay or growth. You don't get bothered. You just maintain the formula like that. If k comes out to be negative, then you are sure it's the decay equation that you have. If k comes out to be positive, then you can even say, oh, this question is not decaying actually. This population is not decaying, okay? But because you've been told and you're given the information, this must work. We must arrive at the decaying equation where k should be negative. So we substitute the information given. We are given 1.5 is equal to 2 as the initial, and E T is 7,250, and then multiplied by K. We are looking for K in this case, okay? And then 1.5 is the same as 3/2. So this is equal to 2e to the power 7,250 K. And then if you divide by 2 and divide by 2, so dividing by 2 this side is like a dividing by 2/1. So if you switch from division to multiplication, we'll end up having 3/4. This is equal to e to the power 7,250 K. Okay, then we apply ln. So ln this side, apply ln this side. Wow, wonderful. So once we have ln, you know why you like ln? Because ln has the power to drop powers. So that power now comes down, 7,250 K is equal to, multiplied by ln E. Ln E is just log E base E. So, which is just 1. So don't even write it. And then here, we divide by 7,250. We divide by 7,250. So we have K is equal to 1/7,250 multiplied by ln 3/4. So this K positive or negative? Let's get back to the graph of log function. Look at this. If this is a log graph, then, well, if we're dealing with ln x as our function, you know that it goes up like that and cuts at 1. That is the value of x. So 3/4 is actually 0 point something. So 3/4 is 0.75. 0.75 is somewhere here before you get 1. So what is the value of y? Is it positive or negative? So you are coming down to negative. All the values of y below the x-axis are negative values. This is just assuring us that, oh, don't worry. The value of k that you have is negative. And so because the value of k is negative, then you go back and say, wow, I've found the exponential decay equation, which is n naught. You fix the n naught, which is 2, and then e to the power, what is k? So I first write t to avoid confusion. So I'll write t multiplied by k, which is 1 over 7 to 50, ln 3 over 4, like that. Well, so I'm sure that the ln has come with a negative. So together I have my power as negative. So I can write it a bit just to decorate it. I'll say 2e t multiplied by 1 over 7 to 50. That is t over 7 to 50 multiplied by ln 3 over 4. Like that. So this is going to be our function. Now we have found the function. What's the next question? The next question now will be, how long will it take for half of the element to decay? That's the question that we're about to answer. Okay, so how long will it take for half of the element to decay? Okay, half of which element? It should be half of the initial. Okay, because you have your initial thing, the first thing that you start with is the initial. So you have 2 kgs. That is your initial thing. Now you're observing what happens. So how long will it take half of my initial to decay? So you go to the initial and divide it by 2. Remember, the initial is 2, so you divide it by 2, you get 1 kg. So now we are talking of how long will it take for 1 kg to decay. So we say, okay, since we have the function as p of t is equal to 2e at t over 7 to 50 ln 3 over 4. So you are told pt is now 1 is equal to 2e t, okay, 7250 ln 3 over 4. We are looking for t now. How long? Meaning what term? Okay, so you need to find the term that will be taken. So you divide by 2, divide by 2, so we have half is equal to e to the power t over 7 to 50, like that, and then ln 3 over 4. Okay, then we apply ln, So when you apply ln, this side will remain with ln half. Ln half is equal to t over 7 to 50, and then ln 3 over 4, like that. Cross multiply, you're looking for t, of course, so you cross multiply, you have 7 to 50, ln half, and then divide by ln 3 over 4. This is going to give us t. So you have found t, like that. Do you worry about decorating it? I mean, no worry. This is just a value of t that they asked us to find. Then question C, a bit interesting as well. How long will it take until there is 250 grams of the element left? Okay, how long will it take until there is 250 grams of the element left? How long? So you say, okay, they are talking about grams here. Okay, but this shouldn't be grams. The initial is in kgs. So you convert your grams 2 kgs. Okay, so how do you convert? Well, you know that 1 kg is equivalent to 1,000 grams. Like that. So now you're given 250 grams. Okay, against X kgs. So you convert. Okay, of course, you're talking of 1,000. X is equal to 250. So divide by 1,000. Divide by 1,000. So you're saying X is equal to, this cancels 100 into there, that is 0.250. 100 into 250, that is just 0.25 altogether. So you get 0.25 kgs. Like that. So you're now saying, oh, I'm given that I have 0.25 kgs. And the initial is still 2. And again, I'm looking for time when that can happen. So this is 7250. And then lane 3/4. Like that. So again, we divide by 2. We divide by 2. So what we get? Or you can write that thing. You can write it, if you don't want to have a fraction, 0.25 is just like 25 over 100, like that. Okay, so 25 over 100, which you can say, okay, but 5 can go there, even 25 can go there 1 times, and 25 can go here 4 times. So now we are dealing, where is 0.25, we have 1/4. So let me write it here. So we have 1/4 and then over 2, okay, is equal to E T over 7250 ln 3/4. So when that happens, this is just like 1/8. So we have 1/8 is equal to E T over 7250 and then ln 3/4. Then you apply ln this side. We apply ln this side. Okay, so now we have ln of 1/8 is equal to T over 7250 ln 3/4, like that. So you cross multiply again, you get 7250 multiplied by ln 1/8. Of course, then divide by ln 3/4. And this is going to give us the value of T, like that. So that's how we find the value of T in that case. So I've answered the application questions. So one thing that you should take home here is that, well, when they say exponential decay, exponential equation, you use the same equation. You use the same equation, okay? But you just observe the value of K. Well, when they say decay, you just need to be sure that the value of K that you get is negative for you to call out your equation as a decay equation. Or if the value comes out to be positive, well, then you're comfortable with calling that equation as the exponential growth equation. So it should make sense now. Thank you for watching. Hope you enjoyed. Don't forget to share with friends.